Hello, this is Professor Mike Labasi, and we're here looking at digital forensics, and we're looking at Module 6 on Windows Forensics. At the time of the recording, this is Topic 6 for my CIS 2808 Introduction to Computer Forensics class. So this, of course, is a CHIF Volume 2, um, Chapter 2. So what I have is the slide deck up. I'm also going to cherry pick some stuff from the slide deck to look at this topic. So this is probably the big one. Windows Forensics itself, no surprise. um, and really this applies to any operating system. And this is, of course, is the order of volatility. And it's pretty obvious that, of course, system is on. If a system is on, then this, of course, applies. There's information you want, if at all possible, gather from the system. And this is going to depend upon if it's locked, unlocked, various things. If it's on a battery, how much battery's left, things like that. But the really come down to it is this. You want to be able to grab as much information as you can before the system is rebooted or shut down. So that's basically right there. Stuff is lost once rebooted. Things like, of course, probably the biggest one is going to be memory. So RAM itself is going to be one of the big ones, but other information, current connections, open files, logged on users. So uh, we'll keep that in mind as we look at the next part here. Now this applies not just to Windows. There's some differences when you come to Windows and Linux and Mac, but the overall process itself is still where you want. So again, non-volatile information. So for Windows itself, memory is probably the top one. Memory and then registry. So that is one specific Windows item itself. And there's, of course, a description of the registry here. And this chapter really goes into a lot of details, a lot of tools to gather both registry, memory, um, imaging disk, things like that. But understand the registry itself. It's going to be good to have a reference of what you're looking for. And of course, this is the Microsoft Docs. And there's information in the chapter that goes in the registry itself. And this is going to be really your main source of all kinds of information. So for example, if a USB was plugged in, what USB was plugged in, its size, its its name, date and time, um, who was logged in. Just we can go on and on, long list there for that. So, but registry is going to be a huge one for that, and event logs. Now, logs are also going to be specific to other operating systems, but there's the event log viewer in Windows, and there's some information inside there that might help with forensics. So, well, also we have this extensible storage engine. It's the JetBlue or the EDB files. So contacts, Windows Live Mail, um, Windows Search is always a good one. So the Windows EDB stores information about Windows Search if someone's looking for something. So there's some stores favorites for Internet Explorer 11. Now, Internet Explorer should be gone by the time of this. Typically it's gone, but here's the thing: you can't really discount the fact that a suspect system could be an older machine and still be running older software. So it's good to keep that in mind. Now everyone's going to be running the latest and greatest um, operating systems and, of course, web browsers, but um, we see less and less of that. Okay, memory analysis, definitely a huge one here. So there's details about itself, the hibernation file. So a lot of Windows laptops, for example, can hibernate, and those hibernation files can store information that can be value um, to investigators. So specifically, you want to look for applications, and of course, what applications have been run, what is being run, any remote access authentication details. Those are really handy. And of course, that slack space of hibernation is created. So there's information about hibernation files, and of course, I mentioned the registry. This is probably the big one. Um, so the chapter itself will talk about where to look at specific parts of registry. And the good part is there's a lot of tools to help you deal with this. And the lab will actually walk you through some of this. But there's non-volatile, like those two hives. And then we, of course, the more volatile ones, the class root, class user, and HKey current config. So look for the underscore current. That could be one useful thing there. But hardware profile and system setup. More important is who is logged in, the HKey users. So an HKey current user, the load active profile of the current user itself. So. And I'm going to go through here, not to spend too much time here. Registry itself, there's a cell with a value and a subkey list. So understand how this works. After you've seen the registry a couple of times, it's not too hard to figure out. And that the previous Microsoft document I had up talks about the details. Now, important thing too is where these registry files are located at. Um, Normally they are going to be under, I think it's under the C, Windows System 32 config folder, yeah, right there. So these are usually hidden files. So a regular web browser, a regular file browser will not show these. You need to turn on view hidden files. Now, if you have any kind of admin access, you can copy these files off for later analysis, or this is where you can point something like Access Imager to grab those files. In this case, password recovery, all registry files here you can see in this screenshot. So you might need to know where to point this for certain tools like FTK Imager. And here's some examples of collecting this information. Here we can see the active computer name, RD06, R2D2. And then we have, of course, the current version windows. That's actually really good to know, is the current versions, install times, in this case, product name, registered owner. You can see this information can be very valuable. Even if the suspect is not the owner, it's still good to know who the owner was. So what's auto start? That's always a good one. What automatic programs are loaded on startup. And again, I mentioned before, USB store is where we look for USB removable devices. And that's going to be a really good one because that might help you track down a later device. So like someone's, sneaking up, they move their plans to rule the world.doc off into a thumb drive. At least you can have a way to track that. So another big one, cookies and cache, especially with web browsers. So we actually have a separate topic where we go into web analysis, but it's hard not to talk about how important that is here. If you watch any kind of 48 hours primetime live, or even this in news, so and so was caught, um, doing something bad in some kind of case, and they found search how to break into a into a network, search results, and of course pages deal with them. Again, this might be trace evidence or it might not be direct evidence, but it definitely is evidence. So, but it's important again to where to look for these for Firefox. And then Firefox, these are SQLite. So SQLite has a viewer. It works on Mac, Windows, and Linux. And of course, Windows File Analysis. Again, we look for these different things in the prefetch directory. That's a good one to know. We can see which files are normally which were opened. We can see how many times it was launched. We can see the date and time in UTC format it was launched. Information in the registry event too about who was logged into the system. So you can see you can trace together who's logged in, what time it was launched, how many times it was launched, so certain files. And then metadata for the files themselves. Metadata is just that. Again, and this is almost a topic that we can apply to Mac and Linux. A file itself is going to have information, even emails. You might not have the actual content of the email, but you can see suspect A was talking to suspect B via email. So we see the email traces, but we can't see what was in the messages, maybe for encryption reasons, things like that. Images, of course, have information inside them about when it was taken, what kind of device. So again, you'll see when you look at this chapter, and when you do the labs, there's a lot of tools. So, and I have a few we'll look at here, but I'm not going to go into make a sort of a tool fest here, and go on and on. But also, yeah, and TFS and FAT has different times for the. So make that oops, make sure you know about that there. All right, there we go. So you just can basically, again, this is important. Users can share information. You can overtly share information about who was going on with what. So again, even though you think the text, the phone calls, the contents of that was maybe protected in some way, the fact that there was metadata showing that is of value. So make sure you look at that in the chapter. That's a big one. File metadata. I think we look at that also later in the course too. There was also something called shell bags. That's a great name. Uh, these are generally when folders are open or closed at least once, and these have information to directories accessed by the user. So there's information inside there. And probably another big one, this is a huge one, is event logs. So for Windows, there's the event viewer. And we'll leave that to the lab. I think you open up in the lab itself. But there's the application log and security log. Security log can show who's logged in, logged off. So that's some really good stuff right there. System components, device drivers. If someone's plugged something in. And so the idea is you can create a timeline of certain events on a system based off logs, metadata, and registry. So again, this is definitely a summary, and I'll show you a little quick demos here, and we'll look at a couple of things. I have a lot of demos here. So I'm not gonna demo regedit, but regedit msconfig. Maybe I'll do msconfig as a review here. But what we have is, there we go. Let's open that up. There we go. So here are on Windows, and this one we actually have Helix launched. And Helix is a sort of a old-looking tool, but it contains a lot of tools inside there. So if you need to have, for example, PuTTY. PuTTY is a fantastic tool for opening secure shell or telnet or SFTP type of connections. So maybe it was found that this user had a connection or has a connection open, or you have credentials to an open server somewhere. You might be able to use this to launch PuTTY. And the thing about Helix is this runs directly off the exe, so this can be off a boot disk, and it's not installing anything onto the system. Now again, big rule is what it is: you don't ever perform this type of analysis on you always, if at all possible, use a copy of the Windows system. Now, some of this non-volatile stuff will be done with a copy, a certified copy of the, of course, the suspect system or drive. But in this case, we can launch this from a boot disk, and there are exceptions to be made for collecting volatile information. So, and yes, you can always say, well, the fact that you plug in a USB is going to leave an entry. It is, but it is acceptable. And that can be shown. It's part of the process. So, but you can open command shells, VNC, PuTTY, and so on. Anyways, there's actually a hasher inside here. So maybe we have this document we found. We can get this hash here, and we can copy that, and we can go something like virus total. We can paste it, and we can see it was this. Oh, it is. In this case, this infected document is infected. So popular threats downloader v37. So we can pull information from this using that tool. And you do that in the lab, so I'm just don't want to show you everything here. And also this tool itself can launch other tools. So first up, you get information about the system. You see who we're logged in, any IP addresses. Do we have admin rights, yes or no? It's very, very important to know what drives are on the system. And with Helix, there's a little arrow here. And of course, we can see running processes. I think you can just copy all this, select all. Oops, no, I don't want to terminate it. So you can kill processes, but we can get a list of processes. And more important is we can launch specific things. We can launch something like this after dark, and we can actually use that to go in and look at things like the MFT table. And then we can get snapshots of that immediately. So it's sort of a hub for launching tools, and there's a lot of them here. One thing we'll look at, of course, will be the Access FTK Imager. This is a fantastic tool. A few tools in this course I will come back to. This is definitely one of them. Autopsy is a huge one. I'll probably say this now. When we get to autopsy, learn it. It's going to be very handy for a lot of labs, especially labs where you need to do your own work, like almost like a final. But you can see here we can get information about the file size, metadata, the owner ID. Yes, Pikachu, who owns you? NTFS control information. There's a lot of information here. So this is going to expose a lot of underlying information about certain files. So JPEGs, things like that. Even this NTFS index file. So, so the properties value here is very great. There's a hex interpreter, um, but the properties tab is where you want to be. So as you use this to look at evidence files, in this case, I've actually opened up a DD file, evidence file. And you also can create a disk image from this. I think the lab has you start it, but cancel it. It does, of course, take a while to create an image, but you can use to create an image. You can add a evidence image here and review it. And another one here to do the open here. Open this new window. Here is Windows 10. So another tool you can use. Again, this would be on a copy, of course, a forensic copy. But if need be, msconfig is a great tool, and we get information about the system here, boot sequences and so on. But more important is this: what's set to start up. We can open Task Manager to see that. But here is tools. This is actually a great little way to launch a lot of tools that are buried down in Windows. Event viewer, there you go. That's our log viewer, event viewer, system properties. So this is some of the tools like FTK will do this for you, and so on. But you can see we can still do this. Maybe verify the tool is correct, computer name, what type of operating system it is, and so on. Internet options, task manager, and so on. So there's registry editor right there. So there's a registry. So this is a great way, msconfig is a great way to dive in and get access to other tools built into Windows. And regedit, of course, is another one. Now, there's something about when you look at labs themselves. And one of them, of course, is other tools you might look at would be of course, browser analysis. I mentioned that before. Like so for Google Chrome, here we have a cache viewer. And of course, if there's Chrome has used anything, it hasn't. Let's try it over here. There we go. So again, browser forensic analysis tools, a bunch of these. Google Chrome. Let's look at the cache viewer. And there we go. So again, fantastic way to go ahead and easily get information that you can get other ways. But again, the idea is the tool is there to simplify the job of investigating. So again, we can see here, double click Google services. You can see what's been clicked on, and so on. So I'm not gonna go through all these tools. There's a lot in this lab you will go through, but I'll talk about one other thing, and we'll look at the Ubuntu forensics here. So I can log me out. And so there's something that this mentions called strings. And strings. I know strings runs on Linux natively. So if you have a binary file, so if I want to look at a binary file, like let's get user bin, I don't know, OD. It'll say this is binary. You want to see it anyway. So if you say yes, that's not very useful, is it? So what we do is we do strings on user bin OD. And this will scrape through a binary file and pull out any ASCII strings. So this is a really, really handy way to possibly pull information from different from files themselves that are binary in nature, but maybe you get information from them. In this case, we can see all kinds of stuff. Now, when you make from the file itself, I have no idea what OD is. I forgot what OD is. So, but there's information side here. I'll give you a case though where this is actually very handy. For example, mobile devices or cache files. So when I say cache file, I don't mean yeah, database caches, things like that. They're normally you have a cache file. It's just a binary blob, but you can use strings to scrape through it and maybe find things. I've used it to I've used it before to find credentials that were cached for a mobile device. So strings is really great, and you'll go through that um, in the lab itself. So at least I believe you do. Oh, it mentions it in the book, so I don't know if the lab goes through or not, but strings. And there might be a way to get that same information from other tools, like maybe Autopsy. You can look at a binary file, and there could be ways to um, grab that same data using a variety of tools. So again, I don't want to make this a a tool demo lecture, but I want to just want to show you real quick some of the important things about um, definitely about collecting data. And this is probably the biggest one. If you walk away for Windows, is the volatile information. Uh, so look at the information in the text about this. Very important, especially the volatile stuff. Also, then some specifics. Again, this is very operating system generic, but there's some specifics for Windows I want you to walk away with. That, of course, is registry, the event viewer, um, and like things like the shell bags, but things like that. So, and of course, we have other non-volatile data, which we looked at previously. Includes deleted files. Um, you can look for logs for deletions, and maybe do a forensics recovery of deleted files, things like that. And of course, if you have like the example, pagefile.sys. So that is actually a pagefile.sys is virtual memory in Windows, and you can take that file, send it over here to Linux, and scrape through it with strings. You might find some, you might not. So, anyways, that's just some examples to walk away from Windows memory collection, Windows forensics, and collection of volatile and non-volatile data. So, thank you for watching. Have a good day.